basicity of amines. Okay, next we studied about basicity of amines. Right here, see amines. Amines are derivatives of ammonia. Okay, amines are derivatives of ammonia. Okay, that means you take NH3. So in these amines, nitrogen is present. So these amines are derivatives of ammonia. Okay, right now you see in amines on nitrogen atom, lone pair is present. When you take amines, in these amines on nitrogen atom, lone pair is present like this. Okay, on nitrogen lone pair is present. Due to presence of lone pair, it can be act as Lewis base. Okay, here Lewis base means it is nothing but electron pair donor. So on nitrogen atom one lone pair is present. That lone pair can be donated by amines. That's why here amines can be act as Lewis bases, because in amines on nitrogen atom one lone pair is present. Okay, and you see when you study about amines, they is generally classified into primary amine. When you write primary amine, generally we take like this, or NH2. Here are alkyl group, NH2 is present, it is primary amine. Secondary amine. Okay, when you take secondary amine, nitrogen, on nitrogen, two alkyl groups are present, or two alkyl groups are present, it is secondary amine, or NH2 is primary amine, and another type is tertiary amine. In tertiary amine on nitrogen, three alkyl groups are present. Okay, so amines primary, secondary, tertiary, and primary amine one alkyl group. In secondary amine, two alkyl groups can be attached to nitrogen. In tertiary amine, three alkyl groups can be attached to nitrogen. Okay, and when you see, we studied about these amines. These are again classified into two types: aliphatic amines, aromatic amines. Okay, so again these amines can be classified into aliphatic amines, aromatic amines. Okay, here aliphatic means without benzene ring. In aromatic amines they contains benzene ring. Okay, so amines can be classified into aliphatic and aromatic, and here see these are also classified into primary, secondary, tertiary. Okay, right now you can see here their basicity, how their basicity can be present. Now we can study about the basicity of these amines. Okay, right, so while studying about basicity, here in amines, here which amine can donate electron pair easily? It is more basic. That's why electron donating groups. Electron donating groups. Okay, generally these are plus I groups. Electron donating groups can increases the basicity of amines. Okay, that means within the amine, if plus I group is present, it can be increases the basicity of amine. Okay, right now we studied about your basicity. While studying about basicity, one by one we studied. So first we studied basicity of aliphatic amines. Okay, first we studied about basicity of aliphatic amines. Okay, in this also we studied in two cases. One is in gas phase. Okay, we studied about basicity of aliphatic amines in gas phase. Okay, when you take gas phase, here the order is tertiary amine. It is more basic than secondary amine, and it is more basic than primary amine, and it is more basic than ammonia. Okay, remember it is in gas phase. It is according to electron donating group. Here alkyl group. Alkyl groups are examples for electron donating group, or alkyl group. It is an electron donating group. That means it is plus I group. So here in tertiary amine, three alkyl groups are present. Here two alkyl groups and here one alkyl group is present. Based on this, here alkyl group can increases the basicity. According to that, in gas phase, we can explain that the basicity order is tertiary amine is more basic than secondary. Secondary is more basic than primary. Primary is more basic than ammonia. Okay, this we have to take in gas phase, right? Now when you study about in another page, that is in aqueous solution form. So in aqueous solution form, while explaining this, here only inductive effect is not useful. Here if you study about basicity in aqueous phase, while explaining about basicity in aqueous phase, the conditions we follow is one is inductive effect. That means according to plus I group can increases the basicity of amine. Okay, and here aqueous phase means it is nothing but polar solvent solution form. So whenever it is present in solution form, here another effect is present, that is solvation effect. That means formation of hydrogen bonding with water. The solvation effect is also present, and here another effect is steric hindrance. Okay, here another effect we applied, steric hindrance. Based on these three effects, we can explain about basicity in aqueous solution or in polar solvent. Okay, while explaining about basicity of amines in gas phase, only we can conclude an inductive effect. By using inductive effect, we can explain about basicity of amines in gas phase. But when we want to explain about basicity of amines in aqueous phase or in polar solvent or in solution form, based on these three conditions we can explain. Okay, so based on that, if you want to explain about that, it depends on alkyl group, and you write basicity order. It is for aqueous solution. But in place of alkyl group, if CH3 methyl group is present, then the basicity order is secondary amine, primary amine, tertiary amine, and ammonia. It is the order. Okay, so when you take methyl group can be present, then in that condition secondary amines are more basic than primary and tertiary. Okay, but in place of CH3, if C2H5 ethyl group is present in aqueous solution form or in polar solvent, if ethyl group is present, in that condition again secondary is more basic, but these two positions can be interchanged. Tertiary is more basic than primary. After this, ammonia is present. Okay, you remember within the problem in alkyl group place, methyl group is present, then the order is secondary, primary, tertiary, and ammonia. If ethyl group is present in that condition, again secondary amine is more basic, but primary and tertiary, these two positions can be interchanged. Okay, right, these are alkyl groups. Now we take another alkyl group, that is secondary alkyl group. For example, on CH group, two CH3 groups are present, like this you have to take it. It is secondary alkyl. Whenever secondary alkyl group is present, here primary, it is more basic than NH3, and next secondary, and least one is tertiary. Okay, so this we applied whenever here secondary alkyl group is present. Okay, right, in place of secondary, if tertiary alkyl group is present, that means around the carbon 3 methyl groups are present. In that condition, basicity, highest basicity for ammonia, after this primary, and next secondary, and least one is tertiary. Okay, it is the basicity order in aqueous solution. Okay, see here two conditions, in gas phase and in aqueous phase. In within the problem, it is, we have to see, that is gas phase or in aqueous phase. If it is in gas phase, directly we write tertiary, secondary, primary. But whenever it is aqueous phase, based on alkyl group, we write the order. Okay, so while solving the problem, we can see within the problem it is given in gas phase or in aqueous phase. Okay, so in aqueous phase it is the order. Okay, right, it is basicity of aliphatic amines. Right, now when you compare basicity of aliphatic amines, aromatic amines, once you see what is the order it is present. So when you say, when you take this, you see basicity order, aliphatic amines. Aliphatic amines are more basic than ammonia. Ammonia is more basic than aromatic amines. So when you write the basicity order, aliphatic amines are more basic than ammonia. Ammonia is more basic than aromatic amines. Okay, once you have to see why this. When you take aliphatic amine, it is present like this. It is an example for aliphatic amine. Okay, so when you see aliphatic amine, in aliphatic amine here alkyl group, this alkyl group is plus IE group. Okay, plus IE group means it is nothing but electron donating group. So electron donating group can increases the electron density on nitrogen atom. Okay, because here plus IE group, it is electron donating group, it can donate electron density to nitrogen atom. So on nitrogen atom, electron density is increases, that's why it can easily donate that electron pair. Okay, by donating that electron pair, it is having basic nature. But when you take aromatic amine means we write like this. AR indicate here benzene ring. Okay, we take like this, or if you write the structure in place of AR, here it is present like this, on benzene ring NH2 group is present, or in place of this we write PHNH2, or we can take C6H5NH2. Okay, we can write any type here. Okay, in these you see here C6H5 group is present. It is electron withdrawing group, that is minus IE group. Okay, so electron withdrawing group means what it is done? It can withdraw electron density from nitrogen atom. Okay, it can withdraw electron density from nitrogen atom. So whenever this phenyl group or aryl group, it can withdraw electron density from nitrogen atom. On nitrogen atom, availability of electron density decreases. Okay, by decreasing electron density, this nitrogen is not easily donate this lone pair, and a resonance structure formation takes place. In that resonance, this electron pair is involved. Okay, so when you take aromatic amine, lone pair which is present on nitrogen atom, that is involved in resonance structures. That why that electron pair is not freely present, so it is not easily donate that lone pair. That's why when you compare aliphatic and aromatic amines are less basic than aliphatic amines. Okay, right. So it is a comparison between aliphatic and aromatic. Right. Now we take aromatic amines. Within the aromatic amines, which is more basic, now we want to see. So when you take aromatic amines, okay, within the aromatic amine, now we see C6H5NH2, or on benzene ring NH2 is present, it is called aniline, and it is an aromatic amine. Benzene ring is present, and it is aromatic primary amine. Now we take another one, C6H5 NHC6H5, diphenylamine. Okay, it is aromatic but secondary amine, NH is present. Okay, now we take another example, C6H5 NC6H5 C6H5. It is aromatic tertiary amine or triphenylamine. Okay, when you compare basicity of these three, in these three, aniline is more basic than these two, because here C6H5, it is electron withdrawing group. That means minus I group is present. Here only one minus I group is present, so it can withdraw electron density from here, but here on both sides it can withdraw electron density. Here on three sides it can withdraw electron density. Okay, that's why here on nitrogen electron density can be decreases, and you remember that minus IE groups can decreases the basicity of amines. That's why when you take aromatic amines, within the aromatic amines, it is aniline, it is a diphenylaniline and triphenyl. In this, it is primary amine, aromatic primary amine, aromatic secondary amine, aromatic tertiary amine. When you take these three, in these three, aniline is more basic. Okay, so you remember that here whenever minus IE group is present, it can withdraw electron density. That's why basicity can be decreases. Right. Now we take another example. It is based on substituent groups. Okay, right. Now we see. In an example, it is given like this. On benzene ring NH2, that is aniline, and next here we take substitution NH2, and here I take NO2 group, para-nitroaniline, and we take another one NH2, and in this place I take CH, para-toluene. Okay, so here you see it is aniline, and it is para-nitroaniline. Okay, and it is para-toluene. Okay, so now we write basicity of these three. Okay, here you see what are the groups present: aniline, para-nitroaniline, para-toluene. Okay, in these three, which is more basic? Now we want to study. All these are aromatic amines. Okay, in all these aromatic amines, here common is NH2 group. In all these NH2 group is common. Now we see here NO2 group and here CH3 group is present. Based on this, we can explain. NO2 group, it is electron withdrawing group, and here CH3, it is electron donating group. Okay, it is a plus I group and it is minus I group. Okay, already we studied that basicity of amines increases whenever plus I groups is present, and basicity of amines decreases whenever minus I group is present. Okay, so if you write the basicity order of these three, in these three, here in third one plus I group is present. That's why if you write the basicity order, here more basic is third one. Okay, here plus IE group is present. Okay, here there are no plus IE and minus IE, so that's why it is present at middle. and least basic is second one, because here which is present, minus IE, electron withdrawing group is present. Okay, like this questions are asking, you have to remember that. So whenever aromatic amines are given, within that substituents are present, if it is plus IE group, in that case basicity can be increases. If it is minus IE group, in that case basicity can be decreases. Okay, right, it is one example. And next one, you see, we take another example. Right, now I take like this, you see, aniline. Now I take like this, NH2, and here I take CH3. Okay, it is toluene, but it is ortho toluene. Okay, and next one, NH2, CH3. It is meta toluene. Okay, and next I take para toluene. Okay, now we compare basicity order of this. Okay, here what you have, what are the groups you have to take in? One is aniline, orthotoluene, metatoluene, paratoluene. Okay, right now you see it is aniline, there are no group is present, but in these three cases CH3 group is present. Okay, here CH3 group is which type of group? It is plus IE group. So plus IE group can increases the basicity. Okay, that's why when you compare these, here basicity can be increases, but you remember here when you write the basicity order for this, in these four groups, if you want to write basicity order, that order, okay, highest basicity is for para. So we take first one, fourth one, that is para, and next one is meta, that is third one, and after this aniline, and least one is ortho. Okay, it is the basicity order. So that means when you write basicity order for toluene, para greater than, meta greater than aniline, and least one is ortho. This is the order you remember. Okay, so here whenever plus IE group is present, more basic is para group. Okay, but and you remember whenever it is an aniline group, okay, on aniline any substituent is present, that is electron donating or electron withdrawing group, always ortho compound is least basic. Okay, remember this point. In on aniline at ortho position, that is electron donating group or electron withdrawing group, any group it is present, ortho compound is always least basic. This point to remember. Okay, on aniline any group electron donating or electron withdrawing group is present at ortho position, it is least basic. Okay, and remember if plus IE group is present, para is more basic, after that meta, and next one aniline, ortho is always it is less basic. Okay, so it is about basicity order for toluene. Okay, right, and next one you take another one. So in place of CH3, here CH3 indicated is a plus IE group. Right, now we take another group, that is NO2, orthonitroaniline, paranitroaniline, and metanitroaniline. Now we write the order. Okay, so you see here what we have to take in, here we take aniline, orthonitroaniline, metanitroaniline, paranitroaniline. Okay, right. Here NO2 group. Now you see this NO2 group is already we studied, it is electron withdrawing group. Electron withdrawing group can decreases the basicity. Okay, whenever you take electron withdrawing group, what is takes place here? Basicity can be decreases. Okay, so when you compare these four, in these four, electron withdrawing group, electron withdrawing group, electron withdrawing group is present, it can be decreases the basicity. That's why when you write the basicity order, here basicity it is highest for. If you write basicity order for this, aniline is more basic. Aniline is more basic because it does not contains any group. Okay, and you already know this is least one. Okay, at ortho position, either electron donating or either electron withdrawing group is present, it is least basic. Now we have to compare meta and para. Okay, so whenever electron withdrawing group is present, in that condition meta is more basic, after this para, and least one is ortho. Okay, remember this. Okay, so whenever plus IE group is present, para is more basic. Whenever minus IE group is present, meta is more basic. Although always it is least basic. Okay, it is about nitro group. Right. Now in place of NO2 group. Okay, now we take another example. That is fourth example. Right. In place of NO2, we take chlorine or bromine. You use chlorine or bromine. Okay, that means nothing but halogen group. Okay, in place of these, if you can use chlorine or bromine. Okay, right. Now you see. So when you compare these, in this case, the basicity order. Here also basicity is highest for aniline. Aniline is having highest basic nature because whenever chlorine or bromine is present, it is halogen, it is having two characters. Okay, whenever you take inductive effect, according to inductive effect, it is plus IE group, sorry, minus IE group. So minus IE group means here it's having electron withdrawing capacity, but when you take mesomeric effect, or according to mesomeric effect, it is act as electron donating group. So two groups are present. That's why here when you compare these, basicity is highest for aniline. Okay, after aniline already we know that is para more basic. After this meta, and least one is always on. Okay, it is the order for whenever halogen. Halogen means chlorine or bromine is present in that, it is the basicity order. Okay, right. And next, fifth example. If you take in place of Cl or Br NH2, that means two NH2 groups are present. Phenyl diamine, two NH2 groups are present. Here NH2 group, this NH2 group is also plus I group. Sorry. NH2 group here, it contains lone pair. So when you write the order, when you write this order, here you see which is more basic. Para is more basic. Okay, after para, next what you take? Meta. After this meta, next one aniline, and least one is ortho. It is the basicity of aromatic amines. Okay, so you remember on aniline, whenever electron donating or electron withdrawing group is present at ortho position, it is always least basic. Okay, right. It is about basicity of aromatic amines. Right. And next one, you see basicity of aryl alkyl amine. Now we take aryl alkyl amine. Okay, aryl alkyl amine means it is on benzene ring, alkyl group is present. On alkyl group, amine group is present. Okay, so here resonance. This lone pair is not involved in resonance. Okay, it is not directly contact with that benzene ring. That's why this lone pair is not involved in resonance, because in between benzene ring and nitrogen, one alkyl group is present. Okay, that's why when you write the basicity for this, if you write the basicity order, it is somewhat basic than aryl alkyl amines. These are somewhat basic than aryl amines. That means whenever you compare aromatic amines and aryl alkyl amines are basic, because here this lone pair is freely present. It is not involved in resonance. Okay, right. It is about basicity of aryl alkyl amine. Right. After this, next, based on hybridization. If you explain about aromatic character based on hybridization, so when you write based on hybridization, you see basicity. Basicity is highest for the nitrogen atom in which sp3 hybrid orbitals are involved, and in which sp hybrid orbitals or nitrogen atom is involved is least basic. Okay, sp3 hybrid orbitals means nitrogen can be bonded with single, and here nitrogen having double bond, and here nitrogen having triple bond. Okay, so the compounds which contain single bonded nitrogen atom, that is more basic than compounds containing nitrogen triple bond. Okay, for example, we take an example. You see RCH2NH2, it is amine or aliphatic primary amine. It is more basic than RCH double bond NH. CH double bond NH means imine. Okay, and these are more basic than RC triple bond N. Triple bond N means this is nitrile, or it is also called cyanide. Okay, so when you write basicity order for amine, imine, nitrile, amines are more basic because it is sp3, imine sp2, and nitrile sp is present. Okay, it is based on hybridization. If you want to write a basic character, sp3 is more basic than sp2, after that sp. It is based on hybridization. Right. Now we compare amine and amide. Okay, we take like this: CH3, CH2, NH2. It is amine. CH3 C double bond O NH2. It is amine. Okay, so it is amine. NH2 is present, it is amine, and here C double bond O NH2, it is amine. Okay, so whenever amine is present, here resonance. Okay, these electrons can be attracted by that C double bond O. That's why here resonance possible. Due to formation of resonance, this lone pair is not freely present. Okay, whenever that lone pair is not freely present, it is less basic because it is not easily donate that electron pair. Okay, so when you write a basicity order for amine and amide, okay, when you compare basicity of amine and amide, amine is more basic than amide because in amine here there is no resonance formation, but in amide here resonance formation is takes place. That's why when you compare amine and amide, here amines are more basic. Right. Now we take another example. CH3 C double bond O NH2. It is an amide. It is called acetamide. Okay. Now we take another one. C6H5 C double bond O NH2. It is also amide, but it is called benjamide. Okay. That means both are amides. In these two amides, which is more basic, now we want to study. Okay. Right now you see here C double bond O is present. This electron pair involved in resonance. Okay. But you see here benzene ring, it is what? Minus IE group and electron withdrawing group. Okay, due to presence of electron withdrawing group with C double bond O, this lone pair, it can be present as freely. Okay, this lone pair can be present as freely. It is not involved in resonance because they are, which are involved in resonance? Benzene ring and C double bond O. These two are involved in resonance. Here this electron pair can be present as freely. Okay, that's why when you compare acetamide and benjamide, in acetamide lone pair is not freely, it is involved in resonance, but here this lone pair is present as free. That's why when you compare basicity between acetamide and benjamide, benjamide is more basic. Okay, benjamide is more basic than acetamide because in benjamide that lone pair can on nitrogen atom it is present as free, but here in acetamide that lone pair can be involved in resonance. Okay, you remember that. So when you compare acetamide and benjamide, benjamide is more basic. Right, now we see CH3NH2 methylamine, CH3CH2NH2 ethylamine, CH3CH2CH2NH2 propylamine. Okay, when you take these three, methylamine, ethylamine and propylamine, when you compare these three, here propylamine is more basic because here CH3 plus IE group, C2H5 plus IE group, C3H7, these three are plus IE groups only, but here when you compare these alkyl groups, here the size is more. Okay, more sized alkyl group is present, it is more basic. Okay, that's why when you write the basicity order for this, here when you compare 1, 2, 3, in these three, here propylamine is more basic because it's having more size. Okay, due to presence of more size, it is more basic. Okay, right. Now we take another example. Right, now we take like this CF3CH2NH2, CCl3CH2NH2. Which is more basic? Now you want to write. Okay, here you see CF3, it is minus IE group. CCl3, it is also minus IE group, electron withdrawing group. Both are electron withdrawing group. Okay, but when you compare these two, it is more electron withdrawing than CCl3. That's why when you write the basicity order, 1 is less basic than 2. Okay, because here CF3, CCl3, 2 are electron withdrawing groups only, but when you compare here it is more power. That's why it's having less basic nature. Okay, right. Now we take another example. CCl3CH2NH2, CCl3CH2CH2NH2. Okay, now we compare these two. Okay, here you see it is CCl3 electron withdrawing group. Here also CCl3 electron withdrawing group. Same groups are present. Okay, now we want to write the basicity for this, but here you see only one carbon, one alkyl group is present. Here two carbons alkyl group is present. Okay, that's why here CCl3 effect on nitrogen it is less. when compared to CCl3 effect on nitrogen, because in between CCl3NH2 one carbon only present, but in between CCl3NH2 two carbons are present. That's why your CCl3 effect on nitrogen less when compared with this. That's why it is more basic. Okay, so we write like this: one is less basic than two. Okay, remember this also. Right. Now we take another example. It is a structure. It is called pherol, and we take another structure. It is called pyridine. Now another one. It is called piperidine. Okay, now we compare basicity of these three: pherol, pyridine, piperidine. Okay, so you see here nitrogen, nitrogen. Okay, in these three here there are no double bonds. Double bonds is not present. That's why it is more basic. Okay, third one, it is more basic because here unsaturation is not present, sp3 is present. That's why piperidine is more basic. Okay, now we compare pyrrole and pyridine. Okay, so here you see in pyridine nitrogen double bond is present, in pherol nitrogen single bond is present. Okay, according to that actually pherol is more basic, but when you write the basicity order, but actually if you want to write the basicity order, here it is: piperidine is more basic than pyridine, and pyridine is more basic than pherol. That means when you compare these two, pyridine and pherol, here pyridine is more basic. Even though double bond is present, pyridine is more basic than pherol, because you see here this electron pair is involved in delocalization. That means here if you want to get here pherol, it is actually an aromatic compound. So for getting this an aromatic compound, 6 electrons are involved, double bond, 2 pi electrons, 2 pi electrons, 4 pi electrons, and these 2 electrons are also involved in delocalization. Due to presence of that 6 electrons, it is aromatic. That means in pherol, this lone pair is not freely present. It is involved in the delocalization. Due to involved in that, it is aromatic. But when you take pyridine, already 3 double bonds. 3 double bonds means it's having 6 pi electrons. Due to presence of 6 pi electrons, it is directly aromatic. In this aromatic nature, this electron pair is not involved. That's why this lone pair, it is freely present. Okay, free lone pair is present. Due to presence of that free lone pair, when you compare pherol and pyridine, which is more basic, pyridine is more basic. Okay, right? It is about basicity of amines and some examples. Okay, so generally basicity of amines can be increases by the presence of plus IA group, and when you compare aliphatic and aromatic amines are more basic than aromatic amines.